Hi guys, another quick one. This lecture is about swap space management. So the goals of this lecture is to talk about what is swap space, how large should it be, where should it be located, and what does it look like. Looks like I did not get to that one. So what does it actually look like? So what is swap space? So swap space is just kind of temporary spillover space. It's actually part of the secondary storage, and it's used by some of the paging algorithms that we talked about. For example, so this is just an example. It's used for other things too. But when performing page replacement, so there's this swap space. We talked about this backing store, that when something was needed to be swapped out, it would be put into the backing store. And so this could very well be the swap space. At some point, it could leave the swap space and then go actually back to maybe your HDD. So, I guess so. The swap space is in the HDD, but it would go back to the HDD proper. And so the next question is, how large should this swap space be? So it's used for a lot of applications. So the general rule of thumb is that whatever the difference is between your logical or your virtual address space and your actual physical RAM, that's what your swap space should be. So whatever this leftover thing, this should be the size of your swap space. Which makes a lot of sense. So if this is all your virtual address space, this is all, you could have a program this large, technically. And we talked about, so if you had to load all or most of it into memory for it to run, which is unlikely, but it could be, you would run out of space. So you have this swap space that you can now use. And the swap space makes it kind of easier faster at least, to move things in and out. So it still takes a I/O cycle to bring it in, and you actually have to access the drive, but excuse me. But it's a little bit faster because of the way that it's set up. So this brings the question of, where should my swap be located? So you could actually carve it out of your normal file system. So you could actually have a space dedicated in your file system for swap. It could be its own partition. So I talked about in the last video how you could make your own swap partition. So it could be its own partition with its own file system. Or it could be a raw partition, which I think is the most common. So in this raw partition, so its own separate partition, but it has no file system or directories. It only has a swap space storage manager, and this manager is optimizing speed rather than storage. So anytime you're optimizing speed rather than storage, so when we talked about contiguous memory allocation, we were talking about the problem that you wanted to fit, so you had these fixed spots, and you wanted to fit these programs in such that you reduced your internal fragmentation. So this was the internal fragmentation here, that this program had some leftover space. So if I'm not going to worry about how I'm going to store things efficiently, and I just am optimizing speed, then hypothetically you could have a lot of internal fragmentation, which is true, you could. And there's an increased risk for it in the swap space. However, things are so short-lived, or they should be so short-lived in the swap space, that it doesn't matter, because as soon as they come out, that place that is wiped. So all the internal fragmentation that could have happened there is gone. So what does a swap space look like? So by default, it's divided into 4 kilobyte pages. So it has this is the actual swap space, but then it also has a swap map. And what this map has is, it has mappings of the number of processes that are actually mapped to that page. So for instance, if this page here has a value of 5, then that means that there's 5 processes that are actually mapped to that page. So that kind of gives an idea of importance of that page. So if it ever had to be replaced, you might not choose that one. Again, really short, quick, to the point. Let me know if you have any questions. Thank you.